All right, guys, this is the big one. This is going to be a long video. We're going to be talking about a lot of stuff. You can, of course, rewind, fast forward, pause, do whatever you got to do at any point. But there is a lot of information to know for this unit. This is a lot of information coming at you. So the first part we're going to do is we're going to learn some new angle pair names. The stuff we've already learned is still in place. The last unit, the first unit that we just did, we had one intersection, something like this. And we would say like angle 1 and 3 are vertical angles. Angle 2 and 4 are vertical angles. Angle 2 and 1 are a linear pair. This is all true, and none of that's changing. That is still all true. What's changed now is we're going to have more than one intersection. So if I say, give me an angle relationship, you have to decide, are they on the same intersection or not? If they're on the same intersection, like 1, 2, 3, and 4, it's going to be one of our old names, vertical, linear pair. But if I said like angle 1 and 5, those are on different intersections. So it's going to be a little bit different. So let's get into the naming system. Hopefully this makes sense to you. So we have two things we have to consider. What are interior versus exterior, and what is alternating versus same side? And if we can figure that out, then we're going to be okay. So the first thing you do is we have to know what start with this word, transversal. A transversal is just a line that crosses two or more other lines. In this picture, this is my transversal. This is the line that crosses the other two lines. The other two lines don't really have a name, so it might get a little confusing. I am going to call them the others, or the other two. So there's the transversal and the other two. When we're doing this naming system, it'll always be three lines. It'll be the other two plus a transversal. If you're only working with two lines, like angle 4 and angle 2, they only use two lines. Then it's not this naming system, it's something else. So we're talking about a naming system using three lines, a transversal and two others. So let's start with interior versus exterior. You decide interior versus exterior. Well, let me list the transversal. Transversal is line C here. Interior versus exterior has to do with the other two lines. So those two green lines, this is the space between the two green lines. Because you can find me in the space between when two worlds come to me. Hopefully you guys know that song. Beautiful song. But that's what it's talking about, the space between the other two lines. What angles are chilling on the interior? It's 3, 4, 5, and 6. We would call those interior angles, 3, 4, 5, and 6. Which angles are chilling on the exterior? Well, the exterior is everything else. This is all exterior. This is all exterior. We're only talking about how it relates to the two green lines, the other lines. 1 and 2 are out there. 7 and 8 are out there. So my exterior angles are 1, 2, 7, and 8. Okay, so interior versus exterior. I hope you have a decent idea of what that's about right now. Let me kind of clean this up a little bit. Look at the original picture again. So the next thing we have to decide is alternating versus same side. Alternating versus same side, you determine that by the transversal. The transversal in this picture is the blue line. So if I picked any two angles, I would have to decide, are they alternating or same side? So like 4 and 5, are they on the same side of the blue line or different sides? If the blue line was a road, I lived at house 4 and you lived at house 5 and I drove to your house, would I ever have to actually cross the blue street? No. We're on the same side of the street. So those would be same side. So I'm going to list these in pairs. So like 4 and 5 would be same side. 3 and 6 would be same side. We can also go outside and same. So those are on the inside and same side. But how about like 1 and 8? Those are on the same side as well. And then lastly, 2 and 7 are on the same side. So we have same side. We have interior, we have exterior. One more little thing we have to know is called alternating. Well, if same side means you're on the same side of the transversal, then alternating means you switch sides. So if I'm at 1, 1 and 7 would be alternating. Why? If I lived at 1 and you lived at 7, I would have to cross that blue street to get to your house. I'd have to. So that is called alternating. How about 2 to 8? Also alternating. Oh, I didn't mean to erase that. 1 and 7, 2 and 8. And then those are on the outside. How about on the inside? 3 and 5, 4 and 6. So I don't have a lot of room here, but 3 and 5 would be an alternating pair. 4 and 6 would be an alternating pair. So you notice, maybe you were thinking this, I left out some stuff on all of these lists that you might think should be on the list. Some glaring omissions. Might be you were thinking, how about 2 and 3? 2 and 3, are those on the same side? Sure, they're on the same side, but we don't care about that. How many intersections does 2 and 3 use? Just one. If they're on the same intersection, we're not going to use one of these new names. We're going to use an old name. 2 and 3 are a linear pair. So that's not what I'm talking about. You might think 2 and 4 are alternating. Yeah, they're on different sides, but again, one intersection. We would call those vertical angles. Now, one that's a little bit different would be like 1 and 6. Those are alternating, but we'll explain later that there's no name for those. So I'm going to leave those alone as well. All right, so the naming system is we're going to mix and match. And I should have written this in a different order, but those are my 4 choices. I'm one of these two. I'm either interior or exterior. I'm one of those two. I'm either alternating or same side. And so that's how we name things. So for instance, if I picked angles 3 and 5, we would ask ourselves 2 questions. Are they on the same side or are they alternating? Well, 3 and 5 are alternating. So that's the first part, alternating. Are they on the inside or outside? They're on the inside. We would call those alternating interior angles. So examples of alternating interior angles would be 3 and 5 and 4 and 6. Those are alternating interior angles. They're on the inside and they alternate. All right, well, if there's alternating interior, what would like angle 2 and 8? What would 2 and 8 look like? Those alternate, but are they alternating interior? And the answer is no. So 2 and 8 are alternating again. Remember, we decided that they're alternating from the transversal. Did I have to cross the transversal? Yes. But these are on the outside, so they're on the exterior of the other 2 lines. So like 2 and 8 is an example. What's the other example? It would be 1 and 7. So we have alternating interior, we have alternating exterior. The next 2 names are going to be very similar, but instead of alternating, now we're going to be talking about same side. So we have same side, interior, and we're going to have same side, exterior. Same side, interior. They have to be on the same side of the transversal. They have to be on the inside. So like if I picked 4, right, this is the inside. So they have to be on the inside. We're talking about 3, 4, 5, and 6. It has to be from those. So let's say I pick 4. I can't do 3, that's a linear pair. I can't do 6, that's on the other side. What is the thing that's on the same side as 4? 5. 4 and 5 are on the same side, interior together. So an example of same side interior would be 4 and 5. Another example would be 3 and 6. How about exterior? Well, where are my exterior angles? 1 and 2, 7 and 8. Those are my exterior angles. But I want ones on the same side. So if I pick 1, the same side exterior would be 8. The other pair would be 2 and 7. So we have same side interior, same side exterior, and then we have alternating versions of those. That's not every combination possible. Those are 4 of the main ones. We have one more that doesn't really jive with the other ones. They're called corresponding angles. Corresponding angles. Well, to correspond, it means like you kind of have the same position. Corresponding angles have the same position on the other intersection. What do I mean by that? Well, if I look at angle 1 is to the left of green and above blue. If I go to the other intersection, which angle is to the left of green and above blue? It's angle 5. So we would say angle 1 and 5 are corresponding. And we would do this with each set. So 1 and 5 are corresponding. Which other ones would fall into that category where they're on the same position but the other intersection? Well, look at angle 4. Angle 4 is to the right of green and above blue. Angle 8 is to the right of green and above blue. So 4 would go with 8. And then I'll go quickly through the other ones, but top, above green, left of blue, above green, left of blue, 2 and 6. And then below green, left of blue, below green, left of blue, or to the right of green, however you want to think about it, 3 and 7. So those are my corresponding angles for this situation here. So a couple little things. First off, corresponding angles, you'll notice like 1 and 5, for instance, they're on the same side, but we cannot call them same side interior. 1 is outside, 5 is inside. If I say same side interior, I mean both angles are interior, and that's not true. So a trick for corresponding is they will be on the same side every time, but you will have 1 in, 1 out. 1 in, 1 out. So like 3 is on the inside. To correspond to 3, I better be on the outside. 3 and 7 are corresponding angles. They're on the same side, 1 in, 1 out. All right, those are the big ones. There's only one other combination, and this last combination does not have a name, but just so you're aware, if I picked angle 1, let's go over the list real quick. 1 and 5, what are they? 1 in, 1 out, same side, corresponding. 1 and 8, what are they? Both of them outside, right? This is the inside. 1 and 8 are both on the outside. They're on the same side, that same side, exterior. 1 and 7, again, they're both on the outside, but this time they're alternating. They cross the transversal. So we have a name for same side exteriors. We have a name for same side interior, alternating exterior. And then corresponding means same side, 1 in, 1 out. But what about alternating? How about like 1 and 6? Those alternate, and I have 1 in and 1 out. So those actually don't have a name. So you'll never reference that. They do not have an official name. So we'll leave that alone. Something you do need to know for sure is same side is sometimes listed. If you Google it, they'll call it consecutive. So it's consecutive interior and consecutive exterior. So if you ever see it called consecutive, they're talking about the same thing I am. All right. That's the naming scheme. We're going to practice the naming scheme now. There's a lot going on here. So instead of 2 lines, I got 3 lines. Sorry, instead of 3 lines, I have 4 lines. And I'm just going to go through, I'm going to pick angles, and we're going to try to figure out what they are. So if I said angle 1 and angle 7, let's start with that. 1 and 7, we're trying to figure out which of these new names do they fall under. Well, 1 and 7, here's what I would do. If I need to know which ones they are, especially as I'm learning this. Angle 1, if I trace angle 1 here, if I make the arc, put a dot on each end. Angle 7, put a dot on each end. And what should happen is 2 of the dots you should be able to connect with the transversal, and we can. So that's the line that tells me the transversal. So I know right now 1 and 7 are alternating. They're on different sides of the transversal. The other 2 dots, the other 2 lines tell me, in this case, that 1 and 7 are exterior angles. So 1 and 7 I would call alternate exterior angles. All right. You might be kind of confused by that. You might look at this and be like, Mr. Brandon, it's not the inside. Yeah. Look at that angle 7. When I reference it with angle 1, it absolutely is on the outside. So it does depend which direction you're going. So 1 and 7 are alternate exterior angles. They cross the transversal. There's one inside, one outside for those two lines. But what if I said like angle 7 and 9? Okay. Again, trace angle 7. Trace angle 9. Connect the transversal. So this is the transversal we're talking about. Where are the other two lines? Angle 7 uses this line. Angle 9 uses this line. 7 and 9, where are they? They're in between the two lines. So 7 and 9 you would call alternate interior angles. I know. We just said 7 was exterior, now it's interior. It depends on which lines you're talking about. So one angle can be interior for one set and exterior for another. Based on this picture, which angles are always going to be exterior? Well, in this picture, those are not on the inside of anything. 1 and 2, 3 and 4. But these angles chilling out in the middle area, like 5 and 6, they're interior for this set, but they are exterior for this set. So yeah, you can be interior for one set and exterior for another. Okay, how about if I circled angle 6 and angle 10? So we trace the angle, put our dots, trace the angle, put our dots, connect the dots, there's the transversal, and we notice they're on the same side. Here's the other line for 6, here's the other line for 7. Well, one is inside, one is outside. So they're on the same side, one inside, one outside. We would call those what? What? It's going to be hard. They're called corresponding angles. So angle 10 and 6 would be corresponding. One inside, one outside on the same side. How about angle 3 and angle 10? Okay, trace the angle, put a dot, trace the angle, put a dot, and connect that line connects those two dots. So they're on the same side. Here's the other line for 10. Here's the other line for 3. This is the space between. You can find them in the space between. Yeah, you can. 3 and 10 are in between. They're inside. So looking at this, what kind of angles are 3 and 10? 3 and 10 would be same side interior angles. Loving it. Let's do one more set. Let's do angle 2 and 12. Angle 2, trace it. Angle 12, dot, connect the two dots that we can. The other two lines, 2 is this one, 12 is this one. Space between, can't find them in the space between. So 2 and 12, where are they? They're on the outside. And they alternate. They're on different sides of the transversal. 2 and 12 would be alternate exterior angles. One more real quick. 3 and 12. Let's look at 3 and 12. 3 and 12. Connect away. So here's the other line for 12. Here's the other line for 3. 3 is on the inside. 12 is on the outside, and they alternate. One inside, one outside alternating. There's no name for that. 3 and 12 have no name. All right, let's make the picture a little tougher. Got a lot going on here. Just going to go around. We're going to figure out which, we're going to do some. I'll list them out so that I have them written down. Let's see here. Let's talk about angle 1 and 11. So 1 and 11. What are we going to do? We're going to trace angle 1. We're going to trace angle 11. Here's the line that connects them. And here's the other line for 1 and the other line for 11. So where are they? Here's the space between. Are they in between? No, they're both outside. And they're on the same side. This is the transversal. They're on the same side of the transversal, friends. So same side of the transversal. Those would be same side exterior angles. I'm going to call that SSE. And don't worry, I'm writing all that every time. 1 and 11 would be same side exterior. All right. How about angle 3 and 7? Trace angle 3. Trace angle 7. connect 3 to 7. That's the transversal. Here's the other line for 3. Here's the other line for 7. Here's the space between. 3's in there. Woo! So angle 3 is in the space between. How about 7, though? 7's not. So either there's no relation, there's no name, or it's corresponding. Remember, if they're one inside, one outside, we can't say they're exterior, we can't say they're interior because there's one of each. So at that point, it's either corresponding if they're on the same side, and it's no name if they're on alternating sides. And these are on the same side of the transversal. So 3 and 7 would be corresponding angles. That's going to be corresponding angles. All right, 3 and 7 are corresponding. Okay, let's keep it going. I love it. Let's do angle 2 and 9. 2, connect the dots. We're going to connect 2 to 9. Got it. Here's the other line for 2. Here's the other line for 9. How about that? Are they in between? They sure are. So they're in between. Is one inside? No, sorry, they're both in between. Are they on the same side or alternating? Well, to go from 2 to 9, you would have to cross the transversal. So 2 and 9 are alternating interior angles. How about if we went from 2 to 8? Okay, angle 2 to 8. Trace angle 2, trace angle 8. We can connect those two dots. So there's the transversal. Here's the other line for 2. Here's the other line for 8. 2 and 8 are outside. So 2 was inside going the other way, but it's outside going this way. So 2 and 8 would be same side, sorry, alternating exterior angles. So 2 and 8 are alternating exterior angles. All right. And then we'll do one more set. Let's do 12 and 7. Angle 12 is these two. Angle 7 is these two. Here's the line that connects those two dots. So 12 goes with this one. 7 goes with this one. Are they in between? Yes, they are. Are they alternating or same side? They are on the same side of that transversal. So 12 and 7 are alternating interior angles. No, they're not. Sorry, 12 and 7 are same side. Man, I am all over the place. Same side interior angles. We got it. All right, it's going to be even harder here. We have an extra line in there. I'm not going to do as many examples. I just want to throw a few at you. Let's start with angle 5 and angle 8. So if I trace 5, if I trace 8, let's see, here's the thing that connects them. Here's the other line for 5. Here's the other line for 8. They're in between. They cross the transversal. 5 and 8 are going to be... So 5 and 8 are alternate interior angles. The reason why this picture is so much harder, let's take a look at another example here. What if I said 1? Nope. What if I said 2 and 13? All right, let's look. 2 is these two. 13 is those two. Are any of those the same line? Like if I connect through this dot, did I hit any other dot? Nope. If I connect through this dot, do I hit any other dot? Nope. They have no lines in common. As a matter of fact, I could delete angle 13 entirely. There is no angle 13 now, and angle 2 is unaffected. So if that happens, there's no relationship. So 2 and 13, no relationship. No relationship. If you don't have a transversal, you don't have a relationship. So 2 would have, the only things that have relationship with 2 are down here. What do I mean? If I were to trace just angle 2 here, I have this line and I have this line. Well, the first one goes to nowhere. The second one goes down here. So 2 has relationships down here, but not on the bottom right, bottom left. For instance, if I said 2 and, let's go 2 and 8. 2 and 8. If I trace 8 here, here's the other line for 8. Here we have one inside, one outside, and they're on the same side. So 2 and 8 would be corresponding angles. All right, so that's a harder picture. They have to have a relationship. They have to be connected by a transversal. If they're not connected by a transversal, then you can't do it. Another example that would be like angle 6. Here's the two lines for 6. One of them goes down here, the other one goes over there. So does angle 6 have any relationship with the bottom right? None whatsoever. 6 and 8, no relation. 6 and 7, no relation. 6 and 9, no relation. 6 and 10, no relation. It would have to be something over here. I'm going to go rapid fire. Let's just go real quick. Here's angle 6. Here's the line. Here's the line for 6. 6 and 12, what would they be? Ooh, corresponding. 6 and 11, same side exterior. 6 and 13, that's actually another no name. There's no name for that relationship. 6 and 14, alternate exterior. See if you can understand why that's all true. All right. So I'm going to stop this video here. That's just the naming scheme. The next video is going to talk about parallel lines and their properties.